So this is the final video for statistics week 2, and it deals with tree diagrams. So tree diagrams are quite a good way of representing conditional probabilities, and you've seen tree diagrams before from GCSE. So with tree diagrams, and the layout's not too difficult to understand. You've got branches that represent events, and when you work along those branches you get different events. So if I work along this branch, this is the probability of A. So for the printing it didn't really come out, and this is the probability of not A. Okay, and if I've got a second event which is B, then I can have the probability of A and B. But what will I have in the middle? Well, this line would represent the probability of probability of B given A has occurred. Okay, so this line here, these lines in between the events, these are conditional probabilities. Okay, and this is a probability of not B given A has occurred. Okay, this is a probability of B given not A has occurred, and this is a probability of not B given not A has occurred. Okay, so from what do we gain from this? Well, what we gain is that if you remember from GCSE, your teacher would have said to you, multiply across the branches and you get the AND probability. And here we go. Okay, probability of A given B times by probability of B equals A and B. Yeah, so look, I'll repeat that again. Probability of A and B, A given B, times by B is equal to the intersection. Okay, and if you think about it, that's actually just a representation of the multiplication formula. Okay, so with these questions here in year 13, when you're doing with tree diagrams, you've really got to think what the conditional probability is. So let's have a go at these first questions. The first question is okay. The second question, you've got to think in a different way. So we've got Rachel, she eats at a restaurant. The probability that she has a dessert is 0.7. If she has a dessert, the probability she has a coffee is 0.6. But if she does not have dessert, the probability that she has coffee is 0.2. So you've got to read the language here. If she doesn't have dessert, or does she have dessert? So first of all, let's draw a tree diagram, and then we'll look at these two questions here. So the first event is dessert. So we've got dessert and not dessert. The second event is coffee or not coffee. Coffee, not coffee. Okay, because obviously these events could all happen. So the first thing that we've got to analyse is what is the probability she has a dessert. 0.7. Okay, and if you read the question, it says if she has a dessert, the probability she has a coffee is 0.6. So the conditional probability C given D is 0.6. Now obviously if she doesn't have dessert, that's going to be 0.3. Okay, obviously if she doesn't have a coffee, there will be 0.4. Okay, if she does not have dessert, the probability she has a coffee is 0.2. So this probability represents her having a coffee given that she's not had a dessert. Obviously this is 0.8. Right, let's look at these questions here. First question, what is the probability she has dessert and coffee? So to get the AND probability, we've got to multiply across the branch. You've got the probability of D, and you've got the conditional probability which represents these branches here. So the probability of dessert and coffee is going to be 0.7 times 0.6, which is equal to 0.42. Okay. And the next question is, what's the probability of her having coffee? Now, this might seem strange to students because it's basically what's the probability of her having one thing which is not in the first set of branches but the next set. We've got to sort of imagine what are the different types of scenarios where she could have coffee. Well, the first scenario is she has a dessert and coffee, and the next scenario is she doesn't have a dessert but she still has coffee. Okay, so whenever you ask these sort of general questions about one individual probability, you've got to look at the tree diagram and try and understand that. So we know what the probability of D and C is. It's 0.42. Okay. Next probability though we don't have immediately in front of us. What's the probability of not D and C? Well, we can get that really easily. Okay, 0.3 times 0.2. And when you add up those answers, you get 0.48. Okay, so that's question 1 there. Right, now question 2 is a bit more difficult. You've got to think in a different way. And there's 2 perspectives that you could take on this. Okay, so question 2. Michelle and Kim are playing a tennis match. The winner will be the first person to win 2 sets. Okay, so 2 sets of games. Kim is the better player, and in fact, whenever they play a set, the probability is 2/3 that Kim will win the set. And then we've got to answer these questions. What's the probability that Michelle will win the set? If she wins the first set, what's the probability that she'll win the match? What's the probability that she won the first set, given that she won the match? So we've got to really understand this. The question is actually starting off with Kim, and her probability of winning is 2/3 for 1 set. And then all the questions here talk about Michelle. And on the tree diagram, you can't take both points of view. You can't have win-loss for both people. It's not going to work. With a tree diagram, it's normally okay when you have one person. It could be like one person playing a computer game or one person scoring a penalty, okay, or choosing one thing over another. But 2 people, different probabilities, it's not going to work. So we're going to have to take one perspective here. You either take Michelle's perspective or Kim's perspective. Okay, so let's take Michelle's perspective. So if I want to take Michelle's perspective, let's try and make the tree diagram. Okay, so the first set of branches will represent set 1, the second set of branches represent set 2, and the third set of branches will represent set 3, because it might get to that stage. Okay, so let's just analyse this then. We'll take Michelle's perspective. Okay, so the probability of Michelle winning, well, if the probability of Kim winning is 2/3, the probability of Michelle winning is 1/3, and her losing is 2/3. Okay, right, next set of branches. So obviously, after they played one set, they'll play another set. And if Michelle wins a second time, that probability is still 1/3. And if she loses, then that probability is still 2/3. Okay. Likewise, if she loses the first set, she could win the second one, but she could also lose the second one as well and lose the match. So essentially, let's just break this down so far. Michelle could win the first set and win the second, and that's game over. She could win the first set, lose the second set, in which case they have to play a third set to decide a winner, 2-1, because it'll be a draw at the moment. She could lose the first set, win the second set, again they have to decide a winner, lose the first set, lose the second set, and she loses the match. Okay, so we've got to look at the third situation, the tiebreaker, if you want to say. So this is a tiebreaker scenario. Oops, should have had that going from here instead. It's my fault. Okay, so I apologise about that, guys. It should be going from there. Okay, I've just drawn an arrow to save myself. Okay, anyway, I'm sure we can manage without with that slight hiccup on my part. So let's just try and understand the first question. What's the probability that Michelle wins the match? Right, we've got to analyse all the possible scenarios where Michelle could win. Well, that could be where she wins the first set and she wins the second set, or she wins the first set, loses the second set, and then wins in the tiebreaker. And obviously she could lose the first set, win the second set, and come back from behind to beat Kim 2-1. Okay? And obviously, as we've been doing the first question, you'd multiply across these probabilities. Okay, so what's the probability of win and win? Well, that's a third times a third. What's the probability of win, lose, win? Well, that's a third times 2/3 times a third. And what's the probability of lose, win, win? That's 2/3 times a third times a third. Okay? And when you add all of that up, you get 7/27. Okay? Right. So, the next question is, if she wins the first set, what then is the probability that she will win the match? Okay, so got to look very carefully with this one. Okay, so for part B, the question was, if she wins the first set, what is then the probability that she wins the match? So if she wins the first set, which is here, that's basically what all the question's about. If she wins the first set, what's the probability to win the match? Well, then we don't need to regard her losing the first set at all, or we're losing the match from that position. So what we can do for part B, where it means if she wins the first set, what's the probability of winning the match? Well, what we could do is 1 minus the probability of her losing the first match and then losing the match generally. Okay, so 2/3 times 2/3 is her losing the match, losing the first match. Sorry, her losing the match given that she lost the first set. And we don't need to care about that, we just take 1 away from that situation. And when you do that, you get an answer of 5/9. Now part C, we've got a situation where you've got conditional probability. The question's asking, what is the probability that she won the first set given that she won the match? So what's the probability that she won the first set given that she's won the match? Now, because it's a conditional probability, we can use the multiplication formula. We can break that into probability of winning the first set and the match over the probability of winning the match. Okay. Now, what's the probability of winning the first set and winning the match? Well, that will be win and win, and probability of win and lose and win. So that's the top of the fraction sorted. Okay. And what's the probability of winning the match? Well, we know from part A what that probability is. Okay, we've done that already. It is 7 over 27, so we don't need to do any further working whatsoever. Now again, you just work out these probabilities by multiplying across the branches, and when you do that, you get a 9th plus 2 over 27 over 7 over 27, which gets you to an answer of 5 over 7. Okay, so that is tree diagrams, and in the textbook we've got the exercise here, page 31, exercise 2E, for you to have a go at. Right, thank you very much, and I apologise for the mistakes earlier on.